Okay. All right, so in this word problem, they've given you the function that you're going to be working with, and they're saying that the average height, h, can be modeled by this function where r is the distance in centimeters between the rows in which the grain is planted. Okay, so we have h, we have a variable h, which is average height of a grain, and it is a function of r, which is the distance between the rows. So h is the output, r is the input. R is the independent variable, h is the dependent variable. Depends on how far you space those rows. Now, based on this model, you are being asked to determine the minimum average height of the grain and what is the row spacing that results in this height. Okay, now looking at this equation, how do you know it's a quadratic equation? The r term is squared. The variable, the highest exponent of our independent variable is squared. So r squared. Now, does this open up, or the graph of this parabola open up or down? It opens up. So when I'm asked to find the minimum, what am I being asked to find? Well, if it's real, in this case, it's going to be real, right? Because it's a word problem. So we're looking for the vertex. Okay, so the first thing we need to do is we need to find the value of r of the vertex. So x sub r, or r sub v, instead of x, it's r, right? Because our input is r sub v, where a is 0.024 and b is negative 1.2a. So how do I find that vertex? Remember, it's negative b over 2a to find the x, or the r value. So if I just substitute in, I get negative 1.28 over 2 times 0.024. Now I'm going to put that in the calculator, and what am I going to get? Okay, so I'm going to just do decimals, because you're going to be asked to round to the nearest hundredths place, 2 decimal places, or 4 decimal places. So we need to be able to round, right? We need to be able to round. We're going to read the instructions, and if the problem tells you to round 2 decimal places, that's 2. 4, there'd be 2 more to the right of the decimal. If it's money, it's always 2, right? Because we have to have our cents. So we're going to read the word problem and see what we're working with in terms of our variables. Okay, so my input is 26.67. Okay, what does that represent? If r is 26.67, what is that telling me in terms of the word problem?
Number of centimeters.
Yeah, this is the row space in centimeters, right? So let's keep that in mind. Now, corresponding to that row space, we should have what? A height, right? So if I evaluate h when r is 26.67, I'm going to have the minimum average height. Okay, so go ahead and now find what the height is. What is h sub v? So I'm just substituting into this equation, substituting in the r value we just found. And what am I going to get?
710.58.
I don't agree with you.
$49.39.
Oh my gosh, I don't agree with you even. Isn't that what we're putting in?
Oh.
16.53.
I agree with you, Mia. 16.53. So make sure you can get that, right? So this is telling me that the minimum average height of grain is 16.53 centimeters. Now remember, it's a word problem, so we write our answer in words and we don't forget our units of measure. Did you hear what I said? Word problems, we write our answers in words, complete sentences, answering the question, and we're including the correct units of measure. If you don't do that, you will lose points. So this is our minimum. Our minimum is the output. It is the Y value. If I ask you where does that happen, when does that happen, you would say when the row space is 26.67 centimeters apart. Does that make sense? Okay, let's move on to the next example. It's about football. So we have the height in feet of a punted football can be modeled by this function, where x is the ball's horizontal distance in feet from the point of impact with the kicker's foot. Based on this model, I'm being asked what is the maximum height of the punt and how far from the point of impact does this occur? So let me just draw a little picture, because I like my pictures. I have a little football player here, right? He's kicking the little ball. Oh, aha! Imagine that! Parabolic motion. You see it everywhere in this world. He kicks the little ball and it goes that way, right? So f of x is the height modeled by this formula, and we do see that it opens down because the leading coefficient a is negative. So we know it's opening down, the graph of the ball's path. And x is the horizontal distance in feet. So let's just mark that. X is the horizontal distance in feet. H is the height. So it's being asked to find the maximum height. So of course, you know, you're looking for the vertex. And I want to know at what x value does that occur? I've been given this function. Tell me what to do first. Okay, so I know A, I know B, and if I really cared, I'd know C.
Minus B divided by 2A.
Okay, so the x value of the vertex is negative B over 2A. Beautiful. So then I have negative B is 1.18 over 2 times A, which is negative 0.01. If I evaluate that, what am I going to get? 59 feet, right? So it's saying after 59 feet, I reach the maximum height. So I know this distance here is 59 feet. Now to find the maximum height, I'm going to substitute in that 59 feet into this function that I have been given. And what is the maximum height? Beautiful. So I would say the max height of the punt is 36.81 feet, and it occurs 59 feet from impact. Yes, ma'am.
So in this, let's just say in this problem, our decimal was just like 36.6 repeating. They said nothing about like rounded. Like how would we just automatically round it to like 36.67?
I'm always going to tell you.
Okay.
I am always going to tell you, unless it's money, in which case you should know.
Yeah.
You don't round up, you truncate for money,
Yes.
right? The bank's not going to give you an extra cent for nothing, right? Josh?
I'm confused why you write myself.
Y sub V? Because I know I'm finding the Y value of the vertex. So that's just the notation I like to use. If I wanted to, could I ask you when it's going to hit the ground? How far? How far? it would hit the ground, not what time, but how far it will be from impact. Right, because I know this distance, since this is symmetric, right, would be another 59 feet. So I would be able to then draw that conclusion based on symmetry, yes?
Also the zero.
Yes, they are. Yes, they are. Excellent. All right, what if I gave you a quadratic inequality and I asked you to graph it? Okay, the only difference here, I mean, you're still graphing the parabola, nothing's different. The only thing that you have to take into consideration is the boundary. Look at the inequality, is it solid or dotted? Once you determine the boundary of the parabola, you recognize that, but then the only other thing you have to do is worry about which section am I shading? Am I shading inside the little parabola or outside the parabola? How did we decide what half plane to shade when we were graphing linear inequalities? I do too, unless I pass through 0, 0. You check a test point. Now, obviously, if you solve for y, or the output on the left, the direction of the inequality is going to tell you whether you shade above or below, depending on the orientation of the parabola. But test points will never fail you unless you don't know how to do it. Computation, in which case we haven't. So we'll do one example, but really this is no different. You've been given inequality, so the first thing I'd like to do is check that inequality. Is it going to be solid or dotted? It's going to be a solid boundary line. So if I wanted to graph this, what would I do next? You like the y-intercept, okay? What's your y-intercept? No, it's not. Yes, it would. It would be a point. So on that test, if you do not label it as a point, you will lose credit. So I like it. I agree with you. I like to see it. There it is. There's my y-intercept. Now what do you want to find? Okay, let's find the vertex. So to do that, I need to know negative b over 2a, which is negative, what's b? Negative 8, right? That's b. And that's over 2 times a, which is a. So what is the x value of the vertex? I agree with you. Now let's find the y value of the vertex. Again, Josh, that little subscript is just saying, hey, I'm finding the y value of the vertex. Okay, so I'm evaluating this function at 4. And again, I'm doing it with the equality to be able to solve and get this information. So what would be the output? Negative 4. So what is my vertex? Okay, let's plot that. And is this going to open up or down? It's going to open up. Okay, so let's just keep that in the back of our mind to make sure we graph it correctly. Can we find the x-intercept, the zeros, the solutions? Absolutely. So I'm taking this and I'm working with the equality, setting it equal to 0 to find those two x-intercepts if they exist. Of course, I could calculate the discriminant and tell you if I have real values, but you will in this one. What are my two factors? X minus 6 and x minus 2. So x equals 6 and 2. So my x-intercepts, because that's what I'm really being asked, are what? Oh, yes, I can. What other point do I know is on that parabola?
6 and 12. Because it's
8, 12.
Oh, that's what I meant. My bad.
Wait, something's not right.
It's 8.
Oh, I did, didn't I?
I said the wrong number.
Yeah, that's all right. We all have issues. It's Monday. Oh, look who's here. Welcome. And a chair's right here, but not your normal chair. Okay, so what other point do I know based on the symmetry of the graph?
8 and 12.
Yes, that is correct.
Dr. Piazza,
Yes, ma'am.
would you like us to graph the axis
That was the very next thing I was going to do. Normally, yes, we would, but right now we're just worrying about the shading, so I'm not going to be so concerned. But yes, that is a critical piece of information of the graph. I would include it for sure. Now, we said our boundary was solid because of the or equal to, so to the best of my ability, I'm drawing this hideous parabola, but you get the point.
Why does it say shade and then check? That makes no sense.
What? I have to, where does it
It
say?
says the shade, and then after that is the test one
I don't know where you're saying that.
on the packet.
Oh. Well, no, well, yes, yes, you were that. Yeah, it is a little odd, isn't it? Okay, we like to use 0, 0 because I do, because it's not passing, the boundary's not passing through that. So if I check the point 0, 0 in, is it true? Is 0 greater than or equal to 0 squared minus 8 times 0 plus 12? No, so this is false. So that means you don't even think about shading that region that has the 0, 0, because you just told me it shouldn't be shaded. So as a result, I am shading inside.
Wait, so you do shade inside or outside?
That's right. There's the, yeah, you got it. Okay, so the only difference is we're looking at a boundary line that may be dotted, and we have to shade. That's the only difference for the inequalities. There is an example, another example for you to practice on your own. We are not going to do that. But I do want to show you that there's a nice little way to solve it algebraically. There is a graphing an inequality on the test. There are not ones where you have to solve it algebraically. But I have to show you, just in the interest of being complete, how to do it.
What do you mean by solving it?
Algebraically, meaning I'm not graphing it, I'm just using the number line. Okay, so using this information, notice I don't really have a y. So the first thing I'm going to do is rewrite the related equation. So I'm just going to get rid of that inequality and rewrite it. X squared minus 10x plus 18 equals -3. Of course, we like to set it equal to 0. Plus, you also know that, just because it's not on the test doesn't mean it might not be a bonus. So perhaps we should, look at things. What would I do next to solve this? Factor, yes, reverse FOIL. What are my two factors? X. Okay, so then I have x equals 7 and x equal 3. At that point, I'm not graphing intercepts. I'm not working with the Cartesian plane. I'm just looking at the number line. So on the number line, I'm going to locate these two values. Now, since this inequality was a less than or equal to, these are actually part of my solutions. Okay, now for kicks, just to show you how this does relate to graphing this in the Cartesian plane, if I were to look at the original inequality, would that parabola open up or down? It would open up and the boundary line would be solid. So think of something that looks like this, right? If I were in 2 dimensions, but I'm not, right? I'm just in 1 dimension. I'm just on the number line. The question is, would I be shading on the inside or would I be shading on the outside? Okay, so to help you identify that, I have 3 intervals. So I like to create a little table to help me. Okay, so I have this interval here. How would I represent that interval? -∞ to 3. I'm testing within the interval. I have another interval here, which is from 3 to 7. And I have another interval here, which is from 7 to infinity. Okay, so these are my intervals that I'm going to look at to help me determine what I'm shading. This is the value that I'm going to choose in the interval. It doesn't matter what value you choose whatever value you want in that interval. Here, I'm just going to choose, well, less than 3, 0 would be good. Between 3 and 7, I don't know, 4. Greater than 7, I don't know, 8. Doesn't matter as long as you're in the interval. Then I'm going to take each one of these values and I'm going to substitute that in here and see which one is true. You're going to do that and you're going to tell me which one is true. Yes, ma'am.
Do you have multiple ones be true?
Yes,
Okay.
absolutely. And if I only had one solution, then, you know, it could be the whole number line or none of it. I mean, yeah, this is for us to find out. Okay, so this is, let's go ahead and evaluate the inequality and see which one is true. So you're substituting 0 in for x and seeing if you get a true statement, 4 in for x to see if you get a true statement, et cetera, et cetera.
Which should be original equality.
Yes. Does 0 yield a true or a false statement? False. What about 4? That interval is true. What about 8? That interval that contains 8. It is false. So that means my solution set is here only. Okay? So that means I would have shaded inside. This is not true. That is not true. So the solution on the number line is including 3 up to and including 7, right? Because it was a solid boundary line. So how can I write that? As an extended to inequality like that? Or as an interval like that? Yes, ma'am.
Will you ever like have the number line be just like negative infinity? Be your solution set? Like, does that like not make sense?
No, it would not make sense.
So it would all, if you have.
Well, what are your options? As an aside, let's think about it, right?
Yeah.
We can either have something like that, right? So you'd have 2 intervals, or we could have something like that, or we could have either this or that, or technically you could have no real solutions, but then, you know, you'd either shade the whole number line or none of it.
Yeah.
Okay?
Okay.
Good? Okay, if you want another practice problem on that, there it is. Let's talk about this one. I like this one. A vacant lot is being turned into a community vegetable garden. Let me draw my little vegetable garden. My little vegetable garden is measuring 15 by 12. Now, needless to say, I may not draw this to scale, but there I have my 15 by 12 little vegetable garden. Now, a path of uniform width is to surround the garden. There's my path surrounding the garden. Let's assume that's uniform width. There's my path. Uniform width. This is the same thing as this, which is the same thing as that. Those are all the same width. If the area of the garden and path is 378 square meters, find the width of the path. So I'm solving for W. Now, for kicks, maybe we want to look at this entire width here and this entire length here, or height, or whatever 2 dimensions you want to look at. How would I represent this? I know it has 15, but it also has what? So plus 2W. Oh, is it? Oh, imagine that. And so what would the width be? Okay. Now, I know the area of the garden with the path combined. Yes. Mm-hmm. Oh, well, let me call that W. Times 12 plus 2W. And how would I solve this? FOIL. Okay, so 15 times 12. 2w, 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 2w squared. So I have 14w squared plus 54w plus 180 equals 378. I'm solving for w, this beautiful quadratic equation. Set it equal to 0. So I have 4w squared plus 54w minus 198 equals 0. Is there a way to make this problem easier? These numbers are kind of large. You want to divide by 4? Is 198 divisible by 4?
54.
Yeah, so maybe divide by 2, right? Yeah, let's go ahead and divide everything by 2. So that's going to give me 2w squared plus 27w minus 99 equals 0. Split the middle. Yeah. 2w squared plus 33w minus 6w. I don't care. You could use quadratic formula if you really want, but I'm factoring.
Where are you getting the 33?
Oh, it's 33.
She split it with 7, so 33.
Wait, those aren't factors in 99. 33 and 3.
Done. Yes.
Oh, you got to multiply by 2.
Mm-hmm. Okay, so if I factor that, I'm going to have w minus 3 and 2x plus 33. This is not the hard part of the problem, right? So w equals 3. I keep writing x. And then 2w equals negative 33. So w equals negative 30. Oh, well, what is that? That represents width. So do I even need to look at this? No, because it can't be negative, right? Distance can never be negative. So I'm looking at w equals 3. So what is the width of the path? Yes.
So it's the second binomial and extraneous solution.
Yes.
Wait, Dr. P.
Yes.
So you're factoring like the 2w squared. How do you turn like
Multiply a by c, right? Find factors of that product that add to give you this, and then split the middle term.
Think about this stuff.
What's here? How did I get this?
No, how do you like the w minus 3?
This?
Yeah.
I factored by group. I just factored by grouping.
It's two different ones. It's only 2w squared plus 33. That's one.
Yeah.
So would you factor out? Is the w?
No.
Oh, she didn't show the, like, the,
Yeah, I did 2 steps in one.
so normally you would like take it and you would have.
I'd take out a W here, and then you can take out a 3 here. I mean, yeah, there's the 3 came from here. The 33 came from here. The W came from here. Miles, let's review how to split the middle, huh? Well, we're not done yet. I need the width of the path. But does your question come before the width of the path or after the width?
Yeah, it's about the splitting the middle.
Yes, ma'am.
So to get the 33 and the negative 6, you chose those because when you multiply them, they go to 190.
Yes.
Okay.
Yes, ma'am. All right, so what is the width of the path? I found W, right? So I need to know what? If I want to know this length and this length, I would then substitute the W in here, or again, W, right? So this would be 18, and this would be 21. So technically the width of this is here, right? The length of this is here. So I could find the area of the whole thing as well, right?
Aren't they just asking for the width?
Yeah.
Yeah, I know, but I'm just saying, if I were to ask you more, we could find a lot more, right? So I'm not going to tell you exactly what we're finding on the test. All right. Here's another one. This one's involves radical equations, radical expressions embedded in the equations. This is a challenge. You're not going to get anything like this, but this is a super fun problem if you want to look at it. This one involves inequalities. For kicks, let's go ahead and set this one up. Since we did talk about how to solve it, let's go ahead and set this one up because that's not a bad one. A ball is thrown upwards from the top of the Leaning Tower of Pisa. Oh, and I know the height. This is, let me enlarge this a little bit bigger. So here I am. Now, if you notice here, it's showing you, well, let's define all the variables first. Initial velocity is 96 feet per second. So we're going to call that V naught. That's an ugly V. V naught. The little subscript of 0 saying at time equals 0. It's starting. If you've had physics, you will have seen that before. So my initial velocity is 96 feet per second. So notice here you have time equals 0. You have your initial position, so S sub 0 is your initial position. That's 190 feet. This is your initial position. S is position. So that's two pieces of information. T equals 0 is your starting time. It's saying during which time period, so this is the question we're being asked, during which time period will the ball's height exceed that of the tower? So if you throw it up, it's this time, right? Until it reaches back down to the height of the tower and then drops to the ground. So all I'm really looking at is the time it is above the height. They've given you the position function for a free-falling object. So it has a gravitational constant in there. So that is a very popular formula, but I'm giving it to you. And it's saying the height S at any time is given by this function. So the height S is a function of time. Let's substitute in what we know. So S sub t equals negative 16 t squared minus, I know V naught, initial velocity, and I know S naught, initial position. It's saying at what time t, so this is the formula I'm working with, at what time t does the height, S sub t, exceed that of the, let's write those words out. Yes.
Why is it negative 9?
Gravitational constant.
Oh, okay.
So, and this is our little, and it makes sense, right? A little problem, open it down because that negative 16 leading coefficient. All right, so it's saying when, no, I should say at what time. At what time will height exceed tower?
Why is it negative?
I'm sorry?
Why is it negative?
Because this is the function.
96.
Oh no, it should be plus. Thank you. Because I probably stopped mid-sentence to write and didn't finish. Okay, so when is this going to exceed the height of the tower? You see how I wrote that inequality? So what am I going to do? How do you think I'm going to solve this?
Find the vertex.
Well,
When you solve it like 190 is the x.
I'd solve it like I would solve any other quadratic equation. This makes it very easy. Because I need to know the time. Well, the time here is 0. But if I can find this time here, then I know this length of time it's been above the tower. What can I do to make this an easier problem?
Factor out 16.
I'm going to factor out a negative 16, leaving me t minus 6. I'm going to set it equal to 0. And technically, I should turn this into an equal sign when I start solving. So I have negative 16t equals 0 and t minus 6 equals 0. So t equals 0. Okay, yeah, I believe it because that's where the ball starts. And t equals 6. So if I'm being asked during which time period will the ball's height exceed that of the tower, what would you tell me? The first 6 seconds. Ooh, that means, yay, we got the right answer. That's really peculiar. Within first 6 seconds. Any questions? Okay, last but not least, let's talk about quadratic regression. Same exact steps that we did with linear regression. We entered in tables. We graphed it for kicks if we wanted to see it. We maybe investigated the table. But then to perform a quadratic regression, same process. The only difference is now at this point, instead of lin reg, like we did before, we do quad reg. That's the only difference. And instead of it giving you a linear equation, it's going to give you a quadratic equation. So what I want you to do is practice, because you will have to do this on the test. It is, I would like you to enter in the input and notice how it's been given to you. So you have to be able to read the table and understand what the table's giving you. In this case, the table is giving you 2 rows that involve the input x and 2 rows. Instead of one long table, they split it into 2 tables. So let's go ahead and do that. Does anybody need me to walk through the steps, or can you do them? Do I?
Did you enter in both tables in one?
In one, yeah. So this would be list 1, for example. List 1 would go like this and then would continue here, right? And list 2 is your fuel economy, your output. Does that make sense?
Yeah.
Okay,
So
so
they just made it easier.
yes, or more confusing depending on how you interpret that. So we're entering our list. So we're going to stat on your calculator, edit, enter in the 2 lists. Make sure again that your lists have the same number of entries in each. Then you're going to go to stat and then calc. And this time you are going to hit quad reg, a quadratic regression. It is going to give you A, B, and C. Confirm that you got this for A, this for B, and tell me what C is. You will have to do this on the test. This is a calculator problem on the test. This is an excellent calculator problem on the test.
Dr. Peters,
Yes,
is there,
ma'am.
like, a certain mode your calculator has to be?
No. I mean, well, I mean, unless you've manipulated it and changed to other things, but it should work. Why? What's happening?
Maybe I missed my list.
Don't you need to like press something to make it display and all the numbers, or is that more?
No, that's if we were doing a linear regression and we wanted the diagnostics on to get the correlation coefficient. There is no correlation coefficient here.
I did mess up.
Okay.
I put 5 instead of 65.
Okay, so tell me, what is C? What are you finding C to be? 1.5, okay. So if I asked you to then write the equation that you got from your calculator on the test, you would actually put these values in, and I may specify which place to round. So that would be your equation, right? If I asked for that on the test. Now, the question that you're being asked is, at what speed would you get the highest fuel economy? So what am I finding to find the highest fuel economy? Fuel economy is my output. So I'm looking for the max Y value. So that is implying I'm looking for what? The vertex. Yes? Since my leading coefficient is negative, I know my graph is going to open down, so I'm looking for my max. You know how to do that on the calculator, right? I told you how to do, showed you, right? Calc, second trace calc, and then find max. Tell me what the max is. This is all calculator. There is nothing to be done by hand on these problems.
Wait, calc what?
So if you go to find the max, do we remember? So I don't have my information in here, but if I wanted to, I could go to second trace, which is calc, go down to max, set the left bound, set the right bound, right? This is not this problem. I do not have the data in here. This is not this problem. I'm just showing you how to find where to go to get the maximum. Then you set the left bound, you set the right bound, then you hit enter, it guesses it, you hit enter again, and it tells you.
How do you set the left bound?
Did you graph it?
I have a question.
Yes.
How do we get to y1? Like, when to store reg equation?
You have to go to vars and store. Okay, let me just do the whole problem.
Oh, I see it now.
Hang on.
Well, did you graph it? Did you like type it into this thing?
You don't have to type it in there. You can just store it.
Oh,
You did? Oh, wait.
You gotta,
Yes.
On the first one, basically, all the numbers stood right, I got it 5 times, but I still cannot decide.
What do you mean you can't get the right answer? Are you, hang on. I can't do 5,000 things at the same time. Are you putting the input and the output as your correct lists?
Yeah, it's on this one.
Okay, can I do this and then I'll check yours? Y'all check me if my numbers are incorrect. Okay, so there's my X in my list 1. So now I'm going to list 2.
I did like -50 to 100 and then -50 or -50 to +50.
You do have to adjust your window based on the data. What did you do? Share with others in case they did it too.
I entered, so I stopped at 40. I will do the
Oh, yeah, that totally changed. Okay, this is not right. I can't talk and do these at the same time.
Go to, Calc, down to Quad Reg.
15, 22.0.
Store Reg, click that, or click bars. And then enter function, and then enter y value.
Wait, so you go to the project and then the store, and then what do you press?
Go to click bars.
Oh.
And then go over to y bars and then enter. Enter.
About 45 more times.
Go to,
My numbers are right.
wait, you have it. I got
Okay.
45.
All right, so I have my lists in here. Then I'm going to go to Stat, Calc, Quadratic Regression, List 1, List 2. I have my input. Remember, to store it, you go to vars, yvars, function. I'm starting it in the first one. So there is the information that we said was true, correct, right? For A, B, and C, I could make my equation, but it's already stored here. Now to graph it, for me to be able to see what I'm looking at, I have to look at my smallest y value, my smallest x value, which is 15. So I'm going to go, I don't know, I like to start at the the axis, y-axis. X max, my largest x value is 70, so let me just do 90, why not? Counting by 1. My lowest y value looks like 22.3, so let me just do 10. And then y max is 30.4, so maybe do 40, I don't know, I just want to see the thing. Okay, so there it is, and then if I wanted to calculate second calc, I want to find my maximum. So then I have to set my left bound. So go to the left of your vertex, anywhere, and then go to the right of your vertex and look in there, and there it is. Okay, so I now have my vertex. When my speed is 45.5 miles per hour, my fuel economy is 30.4 miles per gallon. I went to second trace, which is calc, and then I went to max because this is the graph opens down, so I'm looking for the maximum, and then it asks down here for the left bound, so I went to the left of my vertex, then I went to the right of my vertex, and then it found the information for me. So the question it's asking you is, at what speed would you get the highest fuel economy? So your answer would be what? Yes, at 45.5 miles per hour, I would get the highest fuel economy, which is 30 miles per gallon, right? It depends on if I tell you to round what it is. Jonathan, did you have a question? Miles, did you have a question? Josh, somebody in that vicinity? No, we're good. We can perform regressions. Okay, we have officially learned everything that is going to be on the test. Okay, so if you look at the packet, the only thing left in the packet is a little summary sheet, right? You have lots of practice problems. I left a few examples in the notes for you to do. So you should be able to go back and do those. You have the rest of class, about 20 minutes or so, to work on my math lab. Why not? Crank it out, my math lab. So today's Monday, your test is Thursday. Let me see hands. Would anybody prefer to do the calculator portion early, like Wednesday in class, or do you want Wednesday to be just a review? Just a review? Okay. Yes, of course.
I have a question. Can I use a calculator like this on the non-calculator portion?